substitution and elimination. I'm first going to use substitution to get rid of one variable. Then I'm going to use elimination to actually solve. Okay. So looking at this, which variable should I get by itself? X or the y in the first one, correct? We'll go ahead and down here, and I assume by this level you should be able to get that by itself fairly quickly, correct? X equals -10 minus 4y plus 2z. Yeah? Now, seriously, I crossed off the one I did because what I see all the time is I see people plug in to itself and then get all real numbers, which isn't a very possible case. I mean, we can easily get one that's all real numbers. Actually, it's infinite solutions, but we'll get there eventually. But don't plug into itself. What I'm going to do is I'm going to plug in for x here, and I'm going to plug in for x here. So on the first one, I had 2, -10, I keep putting plus, minus 4y plus 2z plus y minus z equals -1. Distribute, -20 minus 8y plus 4z plus y minus z equals -1. Now let's clean that up. Y's, I have -7y plus 3z minus 20 equals -1. So add 20 to both sides. -7y plus 3z equals 19. Once again, I'm going to kind of underline once I get to the whole standard form. Just kind of draw my attention to it later. You with me there? Now I'm going to do the exact same thing to the other equation. I'm going to plug x in here.
Should we cross that one out?
Yeah, you can. So I have -10 minus 4y plus 2z minus 3y plus z equals 5. Distribute, I get 10 plus 4y minus 2z minus 3y plus z equals 5. To my like terms, I'm going to have 1y minus 1z. And can we go ahead and subtract 10?
Isn't that the -1, correct? Oh, no.
Yes, no? Can we go ahead and subtract 10 from both sides? We should be. So now I have two equations standard form. Okay? And I kind of underline, draw attention. It becomes a problem that we did yesterday. So from here on out, I choose to use elimination. Just I think it's quicker. Yes? So to use elimination, I'm going to go ahead and multiply this one by,
3.
I'm going to go with 3. Get rid of the z. Keep it smaller. Doesn't matter though. So I have -7y plus 3z equals 19. 3y minus 3z equals -15. I get -4y equals 4. So y equals -1. This one stayed the same. This one I just multiplied by 3 to eliminate z. Now just like yesterday, once you have one answer, you go back to one of those two equations. So I'll go back over here. I have -1 minus z equals -5. Add 1 to both sides. Z equals 4. But now that I have those two, I go all the way back to the top. Doesn't x equal that? So x equals -10 minus 4. Y was what? -1? Z was 4. I don't have it in front of me. Is that correct, guys?
Yes.
Okay. So I have -10 plus 4 plus 8. So x equals 2. And I'm going to write it as a point. X, Y, Z. 2, -1, 4. And definitely circle, box, something so I can find your answer. Come back to us? Remember doing this? Don't remember doing this?
I remember doing it.
Yeah.
substitution once, then elimination. It's a lot of work, but you'll get there. Watch little mistakes. I can tell you right now, Transitions just did these problems on their last chapter. And the thing that every year I see through every problem is one little mistake. Because if you're one negative and you carry it down wrong or something like that, it messes up the whole problem. So take these problems slow. Because watch those little mistakes. That's what will kill us. But if you have a little mistake, don't stop the problem. I have a lot of people that get a weird answer and just quit. If you keep going, one little mistake is probably 1 point off. If you quit, probably way more points off. But just FYI, some common sense. Let's do another. Oh, I know, you poor